welcome back to the engine graphics tutorials. In today's session we are going to look at a unique problem involving flat surfaces of isometric. So the problem is there on your screen where we can see the maximum dimensions. Now there is an origin given over here, so ultimately another point of origin we can assume on this side, the extreme corner of course. So on the right side of origin we have the length 70 and our left side it is 60. The maximum height, as you can see, it's given 74. Now to begin with this view, let us assume the diagram and let's proceed. So I have already figured out the master box for this, so we can see, and let us name for our understanding that this is a front view and this is the left hand side view. So as far as the front view is concerned, this side will give us the front view, you can see it, and this side will give us the left hand side view. Now as we witness the front view, let us again divide this into multiple layers. So for better understanding, I have omitted the dimensions and I have divided this part into several layers. So you can see the topmost layer I have named as A on either sides. So this particular is the common height. On this side we will get the length of section A, maximum length, minimum length. Here we will get minimum width and maximum width of A. Same for B, this lower part refers to B, this C, and the last one is D. If you understand it properly, the section A here is made up of two parts, and here also section A is made up of two parts. So it is quite evident that A is having a bifurcation. It is very clear that the bifurcation is given by means of a line. So that means either of this particular trapezoid or this rectangle, one part is closer to the observer. If you refer to this particular part, this is that inclined line which is closer to the observer. Now let me show the arrows also, which will give us the respective front view and the left hand side view. So this arrow will give me the front view, however this arrow will give me left hand side view, LHV. So when I'm looking for front view, this is the closest line which I have. So if you go by this particular view of A, this particular bifurcated part of A, which is this, is the inclined one. So if you match the complete height of this particular part, it matches with this, which says that it is an inclined surface which is closest to us. So we can start with this part also, right? So if we go by dimensions, we can see an inclined part. So we will start drawing that part first. So somewhere here that part has begun and somewhere here it has ended. Now that part is having certain width. So let us draw the width part also. And that is how that inclined surface will be drawn. Now this satisfies not only the left hand side view but also the front view where I can see a rectangle. Now as that part gets ended, there starts this new part. If you see that part has certain length, so from this part we are supposed to start certain length. Now that length is not continuous, of course, it is divided into multiple parts. So it up to this part it is horizontal and then it is inclined. So up to certain part we have made it horizontal, but there is a discontinuity like this. So we will consider that discontinuity like this. And since this is flat surface, this also is flat surface, they probably make up a rectangular surface. Like this. Now that surface, though we can see vertical here, if we match with the front view, that surface seems to be inclined. So from this part there starts the inclined surface. So it goes up to this particular part you can see now there is a bifurcation here also. If you look at part B also, there is a bifurcation which is same as that of A. So in short, this rib is continued not only for A section but also for B. But this part which you are able to see from A to B, where A is having this groove, B is a complete surface which refers to this inclined surface. So under B, the surface which is projected is completely inclined one. On other side, there emerges this part which is the inverted and rotated C, which we can see. This part D which is shown is a continuous slot. It's a empty space, and we can see the evidence that there is a hidden line passing through. So part D is the completely hidden part. It passes through like this, and hence this part has came outside, same as that of this particular inclined surface, which is continued up to this portion. And this particular portion which we are able to see right now, it resembles a rectangle, refers to this particular surface. So at a certain height, there start a surface like this, which is of course we can see as a rectangle. This one coming down gets completed like this. We can see this rectangle, which refers to this rectangle, is connected with these lines. So we will directly connect them with these lines like this, such that this and this lines are parallel. Then it is evident that it is going inside slightly, which we can see like this, and there starts a vertical line. Now this vertical line matches this point, which refers to this line. So from here there has to go a line parallel to the length, and we will club these two lines. Then the lines are coming outside, as you can see here. It's continued down like it has gone down, then coming parallel to the length, going up as a height again, then again coming parallel to the length. At the end it is coming down and gets the things completed like this. From here it is again supposed to go inside, like we can see this line, and there is a straight vertical line. So there is a straight vertical line which will come back and meet these lines. So this additional part which we could see if it was a transparent one will no more be seen, and we will remove that part. Now it is evident that from every point there starts at least 3 lines. So from here also we will get another line which is going inside, so which completes this lower part. As far as this now upper part is concerned, we know that 1, 2, 3 and 4 are parallel lines, and this hidden line resembles this particular surface, which means that it is a through slot. So at certain distance there will be a parallel line here. Here we will match them, and there goes one more line. Now this particular line and the surface enclosed by this line resembles this particular flat surface. At the end there will be a vertical line starting from this point, and the reason because it is vertical, we can see at the end it is a flat surface, which means at the end whatever surfaces are present, they are vertical surfaces. So with that we have completed the conceptualization of this part. The last line which is left out is this, which will come down and meet this line. Of course it has to be a vertical line, though we can't see here, it's a vertical line, right? So which completes our problem. Now let us quickly redraw this problem using the CAD tool so that it will be understood properly. So as you can see, using the given dimensions, I have already figured out the master box, and let us use this thing for the reference, this thing for the dimensions, and let us draw it quickly. So as to begin with, we'll start with this topmost thing where we know this dimensions and this particular rectangular surface we are going to draw. So from this we can see that the dimension, to be precise, the width of these two surfaces is 8, the spacing between them is 12, and their length is 24. So let's start drawing. From this point I'll draw a length of 8, then there will be a spacing of 12. For timing I'll draw even that line of 12, and then again 8. That in between surface is not more required. Thereafter the length of 24 I will draw. So students, I am speaking in terms of length and width so that there should not be any confusion between dimensions. Even this is the length 24, the width 8, again length 24. As you can see, these are connected directly with the point which is at this height, which is this. The height, of course, we can see is mentioned on the other side, which is of 26. So at a distance of 26, of course, I am going to draw a line. Now this is the height, of course. This particular length, let us try to figure out. It is given is 28. So the width in this manner is 28. This coming down again by 26, and it's get completed here by 28. Now we know that these 2 points are connected. Let them be connected properly. And now thereafter I am going to draw a line parallel to this. So line parallel to this line from this point will be attached with this directly. There will be 2 more lines I will draw parallel to this from this point and this point. Make sure that they are properly started. Like this. You can see these lines are not completed in the actual diagram. They hold certain length of 26 only, which we will show afterwards. So thereafter, once this thing is done, let us go for this particular part, which is of length 8. It is having this much width. So we can see in the diagram they are connected from this point going up to this height. The height of this part also is 26. You can see it here. So even from this point I'll draw a line of height 26, and from that point I will directly join this thing. Now I know that to this line there is a parallel line starting from this point, and it is at a length of 8. You can see like this. This length has got completed here, and there starts a vertical line coming down again by 26, goes in this direction by 8, completes that part. This is how that part is completed. We can see it properly here. Thereafter, this length and this height, if we can figure it out properly, this particular length we will have to figure out. The total length is 70, of which 24 plus 8 is 32 has gone, plus 8 will be 40 gone, so the remaining distance will be 30. So this length of 30, and then again equivalent height will have to see. Now this is going up, not completely, it is the actual length which is 26 minus this height of 8. So the height by which it goes up is 26 minus 8, which is equal to 18. So it goes up by 18, then travels by 30, then comes out down by 18, and again gets completed by 8. So let us finish it. So like this line will not be a completed one. We will draw a line of height 18. It will come outside parallel to the length by 30. Then it will come down then it comes down again by 18. It is direction 8, goes up by 26 again, and there it comes back and gets completed with this particular surface. As we can see it here, that is how we have completed the surface. Then it goes inside. Let us try to understand what is this dimension. If you see, the total dimension is 60, of which 28 if it goes, the remaining dimension is simply 32. So in this, it goes inside by 32 only, then it comes down again by 26, and then it comes outside by the remaining distance of whatever may be the distance. It will be 24 here, we can see it. Then another line will start from this point, it will come and finish this problem here. Now of course we can see in the diagram, this line, this vertical and this, they are meeting. So let us quickly draw them. So from this point there will be a line going inside. Now I am less bothered about what dimension it is going, though I know it. From this point it will go inside, and from this point it is supposed to come and meet this point. So that is how these are the additional lines, which I will not delete. I will maintain them as the construction lines. Like we can see, they are meeting at one point. Now some minute details are remaining, like this line is going inside starting from this point. So from that point we'll start a new line, we'll go inside. I will take it little ahead, and extra part of course I will remove, so which completes my lower part. Now I need to go in upper part and finish this stuff. That is little tricky. We have to see that the maximum height of this part is 26, however this is inclined, so we have to take a vertical projection up to 26, and then we'll have to match it here. So to do it, I'm following this strategy. Basically I want to project that distance here at this level, so I'm drawing a line like this. Then I will draw a line down by 26, and then I will project it inside till it touches this surface. You can see it, this surface. So the point obtained is this, which I will simply transfer to this line. The distance I know is 12, and that is how they are connected. So that the extra lines I will remove out, which are not required by me, and these lines I will turn them to construction, and main lines I will convert them to outlines. So as you can see, we have highlighted the important points. Let me quickly repeat this logic of what we have done. You can see in the problem this height is of 26, however the surface is inclined, so this length is not 26, only this height is 26. Now we have to plot this height at a distance 8 from the extreme point, and for that what I have done is, from this extreme point, which this distance is already 8, I have projected this line on this particular surface or this particular master box line. Then I have came down by 26, so that now my vertical distance is 26, to which I have projected on this line. So that is how the point obtained. This height is 26, and that is how this lot is obtained. After that I will add a line starting from this point, which will go inside and which will meet this inclined line. Of course it has to go up to the end, but we can't see the hidden part, and that's why we will maintain it here. The extra part I will remove, and the last line which I have to draw for this part is starting from this point. It will go down, but we can't see the complete part like this, and that is how the part gets completed. You can see it. Now let me make these lines even darker, and that is how my problem gets completed. At the end I will add only required dimensions, and that is how my problem of flat surfaces using isometric drawing gets completed. Here the important stuff was this particular distance of 30, this particular height of 18, even this lines, this matching of multiple lines, and that is how the problem gets completed. Thank you so much for watching this video. If you have liked it, please subscribe to the channel so that you will be updated with the new lessons, new learnings. Thank you.